Solid modeling. Solid modeling is the most advanced method of geometric modeling in 3 dimensions, i.e., x, y, and z axis. Solid modeling is the representation of the solid parts of the object on computer like real-time objects seen by naked eye. In general, part module is used for this purpose, known as part modeling. Tools used to design 3D models are known as modeling tools. For this purpose, following part modeling tools are used: Extrude, Revolve, Hole, Filet, Chamfer, Rib, Thicken, and Offset. Extrude command is used to take a 2-dimensional profile and converting it into 3D by giving it some thickness. This thickness is known as length of extrusion. A simple example of this would be taking a circle and converting it into a cylinder. Click Ribbon Model tab, Shapes panel, Extrude to access this option. Following method is used for Extrude command. A. Select the 2D sketch to be extruded. B. Specify the direction and length of extrusion in 3rd axis. C. Specify whether the object to be extruded as solid or surface. D. Resultant object will be created. Revolve Feature. This command is used to model 3D axially symmetric objects by taking a 2-dimensional profile and revolving it about a center line. While creating a sketch for the Revolve feature, it is important to think about the cross-sectional shape that will define the 3D geometry once it is revolved about an axis. To define hole in its center line needs to be at radius units distant from the 2D object. Click Ribbon Model tab, Shapes panel, Revolve to access this option. Following method is used for Revolve command. A. Select the 2D sketch A to be revolved as shown in figure. B. Specify the axis of revolution B. The distance between 2D object and centerline specifies the hole diameter at the center of resultant object. C. Specify the angle of revolution theta. Quantify the covered volume about the center line, i.e., 180 degrees in the given case. D. Specify the object to be revolved as a solid or a surface. E. Resultant object will be created. Hole command is used to drill holes in 3D parts of simple and standard sizes. Various predefined standard hole sizes enhance its importance because correct hole type and size need to be defined only. Click Ribbon Model tab, Engineering panel, Hole to access this option. Following method is used for hole command. A. Select the 2D surface on which the hole needs to be drilled. B. Specify the references in 2 axes to position the hole at a given location. C. Specify the type of hole, i.e., simple hole or standard hole. For simple hole, follow next step. For standard hole, select the type of hole that will specify the hole depth and diameter. D. Specify the dimension of axis references and hole diameter. E. Specify the depth of hole. F. Select countersink or counterbore if required. Specify their dimensions as well. G. Resultant hole will be created. Filet Feature. This command breaks the sharp edges of a model and rounds them. It does not need a sketch to create a round. Only edges need to be selected and fillet radius needs to be specified. Round command is used in PTC Creo to fillet edges. Click Ribbon Model tab, Engineering panel, Round to access this option. Following method is used for fillet command. A. Select the relevant edge to be rounded. Press Ctrl plus RMB for selection of more than one edges. B. Specify the fillet radius. C. Resultant profile will be generated. Chamfer's command is used to taper or bevel the sharp edge or a corner. 2 types of chamfers can be created, i.e., corner chamfer and edge chamfer. Corner chamfer is used to create a bevel surface on the vertex connected with 3 edges. Edge chamfer is used to create a beveled surface on the edge or group of edges. Click Ribbon Model tab, Engineering panel, Chamfer, Edge, or Corner Cham. Following method is used to create chamfer. A. Select the type of chamfer to be used, i.e., edge or corner chamfer. B. For edge chamfer, select the relevant edge and define the chamfer variables, i.e., x, y, x, 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 theta, or x, 45 degrees. C. For corner chamfer, select the relevant corner and define the chamfer variables, i.e., x, y, z. D. Resultant chamfer will be created. Fair to access this option. In Profile Rib, two-dimensional sketch is created between two surfaces and the rib applied to the reference object. Only one rib can be created at a time. Following method is used for Profile Rib. A. Identify the two adjacent surfaces where Profile Rib needs to be applied. B. Specify the reference point from References option to define the profile of resultant rib. C. Draw an object line between specified reference point. D. Specify the thickness of rib. E. Resultant rib will be created. In Trajectory Rib, rib is created perpendicular to the sketch profile inside surrounding edges. More than one ribs can be created at a time. Following method is used for Trajectory Rib. A. Define the references on relevant edges by using References option. B. Draw the trajectory or path of ribs between relevant edges that need to be created. C. Specify the thickness, draft, and roundness of ribs. D. Resultant ribs will be created. With Thicken tool, thickness of specified surface or an enclosed boundary can be defined. The applied Thicken feature can further be used as add or remove material from the reference object. Click Ribbon Model tab, Editing panel, Thicken to access this option. Offset feature defines the thickened surface at a specified distance. The same can further be used for add or remove material from the reference object. Click Ribbon Model tab, Editing panel, Offset to access this option. Concept of Edit feature. To modify the parameters of already saved features, Edit feature is used. For this purpose, Reference feature from the model tree, selected by right-click and selecting from drop-down, edit the definition of selected object. The working area of Reference feature opens up, and all options can be modified again. Click Model Tree, RMB on selected feature, edit the definition of selected object to access this option. Advanced Modeling Tools. These tools are used to create complex geometries in 3D objects. Following tools are used in PTC Creo to perform advanced modeling. Sweep Feature, Lofted Feature, Coil Feature, Thread Feature, Shell Feature, Face Draft Feature, Replacing Face Feature, Boundary Patch Feature, Stitching Surfaces Feature, Sculpt Feature, Lofted Feature. It is used to create a 3D feature between two different or same cross-sections. Blend command is used for this purpose in PTC Creo. Two parameters are defined in this case, namely sections and offset distance between both sections. Click Ribbon Model tab, Shapes panel, Loft to access this option. Following method is used for blend command. Specify the section 01 i.e. the beginning of loft profile as specify the section 02 i.e. the end of loft profile. C. Specify offset distance between both sections. D. Repeat step B and see if there are more than two sections in single lofted object. E. If the vertices of two sections in contact are not same, make them equal by either dividing the perimeter or any other editing tools. For example, lofted profile between circle and square, square and triangle, etc. In this case, divide command is used for this purpose. In the example, two sections are used. Section 02 is square with four corners as vertices, while circle has no vertices at its boundary. Click Ribbon, Sketch tab, Editing panel, Divide to access this command. Coil Feature. Centerline and solid line parallel to it are used to define parameters of spring. Centerline specifies the axis of revolution of coils, while solid defines the height of the spring, and the distance between centerline and object line specifies the diameter of spring. Pitch or number of turns need to be specified as well. Sweep object need to be specified to define the cross-section of wire of the spring. Click Ribbon Model tab, Shapes panel, Sweep, Helical Sweep to access this option. Following method is used to define helical spring. A. Specify the height of spring H by defining straight line using line command. B. Draw center line at spring diameter distance D parallel to the straight line drawn in step A. C. Draw the circle of spring wire diameter D at one end of straight line where two construction lines intersect each other. D. Specify the pitch P or number of turns N of spring. It has following equation. P equals 1/N. E. Resultant helical spring will be modeled. Thread Feature. This command is used to create a thread/tap feature on a cylindrical face. A thread is added to the outer cylindrical face, whereas a tap is added to the inner cylindrical face holes. For this purpose, helical sweep command is used in PTC Creo. Helical sweep object is created on the relevant cylindrical face. Thread profile is adopted by sweep object while the remaining parameters are same as in helical sweep. Thread feature. This command is used to create a thread/tap feature on a cylindrical face. A thread is added to the outer cylindrical face, whereas a tap is added to the inner cylindrical face holes. For this purpose, helical sweep command is used in PTC Creo. Helical sweep object is created on the relevant cylindrical face. Thread profile is adopted by sweep object while the remaining parameters are same as in helical sweep. The shell feature hollows out the inside of the solid, leaving a shell of a specified wall thickness. It specifies the surface that wanted to be removed from the shell. If surface is not selected, a closed shell is created with the whole inside of the part hollowed out and no access to the hollow. In this case, necessary cuts or holes to achieve proper geometry can be created. Thickness of the shell can be defined. Independent thickness values for each surface can be defined as well. Click Ribbon Model tab, Engineering Panel, Shell to access this option. Following method is used for shell command. A. Select the reference 3D object to create a shell. B. For open shell, select the surfaces that needs to be removed. C. For closed shell, surface selection not required. D. Specify the wall thickness of shell in both cases, i.e., open or closed shell. E. Resultant feature will be formed. Face draft feature. The draft feature adds a draft angle from -89.9 degrees to +89.9 degrees to individual surfaces or to a series of surfaces. It can only be applied to those surfaces formed by tabulated cylinders or planes. The part models created in Foundry use draft allowance of 1 degree to extract them from mold with ease. Figure 5.4.6 illustrates a draft feature with draft angle of 15 degrees. Click Ribbon Model tab, Engineering Panel, Draft to access this option. Following method is used for draft command. A. Select the surface that needs to be tapered. B. Specify the hinge surface and draft edge AB to define draft direction. C. Specify the draft angle. D. Resultant feature will be formed. Replacing face feature. This tool is used to replace the existing surface of 3D object with a defined surface or a face. The defined surface should intersect with the existing surface. New surface can be created by using Sketch. Boundary patch feature. This tool is used to create a patch of surface between the predefined enclosed boundary. For example, the top of 3D object enclosed with a flat surface using boundary blend by selecting the boundary at the top. For this purpose, boundary blend command is used in Creo. Click Ribbon Model tab, Surfaces panel, Boundary blend to access this option. Stitching surfaces feature. Combination of more than 2 surfaces can be created in this feature, known as quilt. A quilt represents a patchwork of connected non-solid surfaces. A quilt contains information describing the geometry of all the surfaces that compose a quilt and information on how quilt surfaces are stitched, joined, or intersected. A part can contain several quilts. Quilts can be created or manipulated using a surface feature. Sculpt Feature. This tool is used to create a transform geometry in the form of sculpt from a predefined sketch. For this purpose, Warp tool is used in PTC Creo. 2D sketch is drawn on specified surface of 3D object. This sketch is elevated in 3D shape by specifying height of sculpt. Click Ribbon Model tab, Editing Panel, Warp, Sculpt to access this option.